Hello, I'm Professor Ryne, Department of Mechanical Engineering, Vimaljyothi Engineering College, Chamberi, Kannur. I welcome all of you to this course on refrigeration and air conditioning. In this lecture, we will see the topic simple vapor compression refrigeration cycle. Our domestic refrigerator, air conditioner, water cooler, etc. are working on a cycle called simple vapor compression refrigeration cycle. Before talking about this subject, I would like to explain second law of thermodynamics, that is Cauchy's statement. According to Cauchy's statement, it is impossible to construct a machine which, while working in a cycle, will pump heat from low temperature to high temperature without the help of an external agency. Heat will flow from higher heat intensity to lower heat intensity only. That is, heat will flow from higher temperature to lower temperature only. If you want heat to flow in the reverse direction, that is from a cold body to hot body, if you want to pump heat, you need to supply some work input. That is, you can pump heat from low temperature to higher temperature if you provide some work input only. Then only you can pump heat from lower temperature to high temperature. Otherwise, heat will always flow from higher temperature body to lower temperature body. So this is the Cauchy statement. Now, this is our domestic refrigerator. At the top, you can see the freezer. You have a coil wound over the freezer, that is called evaporator coil. This is the place where we are getting the chilling effect. Now we have another coil called condenser coil, that is present rear side of the refrigerator, that is outside. And you have a at the bottom you can see a compressor, a sealed compressor. You can see a black colored compressor which is placed inside a shell. So that is called hermetically sealed compressor. That is actually a reciprocating compressor. Now you have one more device called capillary expansion device. In this case, that is in a smaller capacity system, we have a capillary tube as an expansion device. But whereas in some higher capacity systems, instead of capillary tube, we will be using an expansion valve. This diagram will give you a clear idea about various components. Now this is the front side where door is present, and this is the rear side, and this is the place where we are placing all the food items, etc. Now at the top you have a freezer here over which evaporator coil is present. Now this is the rear side, and you have condenser coil present there. Okay, now we have expansion valve here. Also you can see a compressor at the bottom, the hermetically sealed compressor present inside, that is completely placed in another casing, that is completely insulated from this place, so from this region. Okay, so because heat in the compressor, some heat will be there, so that heat should not enter into this chilled space, so it is completely insulated from this chilled space. So that heat will be removed by using some air circulation like this. So that compressor is completely placed in a casing region where it is completely insulated from this place. Now this is our window AC. This is the wall, and this side of the wall you have the room to be cooled, and this side of the wall, that is here, this is the outside air. So this is called evaporator coil, and you have a fan or blower here to blow cool air, chilled air into the room. And this is the another coil called condenser coil. So this, by using this blower, hot air is blown to outside. So you have the compressor present at the bottom and the expansion device here. So in this case you have two blowers here, that is used for increasing the airflow rate only. So all other connections, all other components are same, like evaporator, compressor, condenser and expansion device. Now this is simple vapor compression refrigeration cycle. It has got components like compressor, condenser, expansion valve and an evaporator. This hot side, this red color side is called a higher pressure side, and this blue color side is called lower pressure side. That is, condenser is in the higher pressure side and evaporator is in the lower pressure side. Now this compressor and the expansion valve together are maintaining a higher pressure on this side and a lower pressure on this side. Now see, Now, so that means a fluid called refrigerant. A fluid called refrigerant is circulated through the cycle. During the circulation, what happens is this refrigerant sucks the heat from the space to be cooled. This is the region where it is to be cooled. So this refrigerant, when it circulates, you can see the arrow direction of the refrigerant flow is given by that arrow indicates the direction of heat flow. I mean direction of refrigerant flow. So during this flow, this refrigerant sucks the heat from this space to be cooled and reject that heat to outside air. Now refrigerant is a fluid which is used in a refrigeration system whose main function is to absorb heat from the space to be cooled and reject that heat to outside atmosphere. Commonly used refrigerants are R12, R22, R134A, R410A. Now, you are choosing the refrigerant in such a way that refrigerant is in the vapor stage at atmospheric conditions. That is, during the at room temperature, refrigerant is at a vapor stage. So that means the boiling point of the refrigerant should be well below the atmospheric temperature. That means the refrigerant which we are using in this cycle is having a property with its boiling point well below the temperature, well below the normal atmospheric temperature. That means refrigerant should be in the vapor form. So vapor refrigerant we are choosing. So a refrigerant in the cycle you are choosing in such a way that it is in the vapor form at the room temperature. Now that refrigerant is filled here. Now when the system when the system is in off condition, everywhere we are charging this refrigerant, and when after charging, when the system is in the off condition, everywhere refrigerant will be in the vapor form. Now when we switch on the compressor, the system starts working. What is the function of compressor? Compressor is the device which maintains a higher pressure in condenser side and lower pressure in the evaporator side with the help of an expansion valve. So all compressor and expansion valve together are maintaining a higher pressure on condenser side and lower pressure on the evaporator side. Now why it is done so is, as I said earlier, refrigerant is in the vapor form at room temperature. Now when we increase the pressure of the refrigerant, what happens is temperature also increases. Now when we we know that when a gas pressure is increased, it can be condensed very easily. That means we when we switch on the compressor sucks the refrigerant from this region. Okay, now this expansion valve will prevent entry of the refrigerant into this side. Okay, so all the refrigerant which is present in the evaporator is sucked by the compressor and it is compressed to higher pressure here. So, and that means here a lower pressure is maintained and here a higher pressure is maintained by this compressor and expansion valve together. Now, when higher pressure refrigerant enters into the condenser, due to compression, its temperature and pressure increases. So we have a higher pressure, higher temperature refrigerant after compressor. Okay, so that higher pressure, higher temperature refrigerant enters into the condenser. Now everywhere, now here you have a higher pressure, higher temperature refrigerant, and outside you have a normal air which is at room temperature. So here you have a higher temperature refrigerant and here you have a room temperature air. So definitely heat will flow from this condenser to outside air. So that means refrigerant will reject its latent heat to outside air because its temperature is very high. Now so what happens is it rejects its latent heat and hence it condenses. So after condenser, it refrigerant condenses and here you can get a hot liquid. Okay, now after condenser, now when this hot liquid enters into the expansion valve, what happens is there is an expansion. A liquid expands here. So the refrigerant expands when it passes through the expansion valve. Due to that, what happens is a part of the liquid vaporizes. When a liquid pressure on the liquid reduces, it vaporizes. A part of the liquid refrigerant vaporizes when it passes through the expansion valve because refrigerant expands. Pressure acting on the refrigerant is less after expansion valve. So a part of the refrigerant vaporizes. Now we know that any refrigerant, any fluid to vaporize, it needs some latent heat. So here what happens is a part of the refrigerant vaporizes by absorbing the heat for vaporization from the remaining liquid. So what happens? Remaining liquid the temperature of the remaining liquid reduces. That is, when refrigerant expands during its passage through the expansion valve, a part of the refrigerant vaporizes, and the latent heat for vaporization is taken from the remaining liquid. So there is a drastic drop in temperature in the case of the remaining liquid, whereas a part of the refrigerant is in the vapor form. So here you can see, after expansion valve, temperature of the liquid refrigerant drops to a very low value. Now when this low temperature, that is called flashing. Okay, so that means when a liquid refrigerant at higher pressure passes through the expansion valve, it flashes. Flashing means it vaporizes. A part of the liquid refrigerant vaporizes by taking its latent heat from the remaining liquid. So remaining liquid will be lower at lower temperature. Now that remaining liquid, which is at lower temperature, which is at very low temperature, passes through the evaporator coil. Now here the temperature of the refrigerant which is passing through the evaporator coil is very lower than the outside air temperature. Okay, or the space to be cooled. Here you have a normal, at the beginning you have a normal temperature, and here we have a lower, very low temperature refrigerant is entering here. So what happens is, heat will flow from this space to be cooled to refrigerant which is at lower temperature. So it, from here heat enters into the refrigerant. So during that, this heat will be its latent heat of the refrigerant. So refrigerant absorbs its latent heat during its passage through the evaporator coil and gets vaporized. Next, after evaporator, you have a vapor refrigerant is coming out. So that refrigerant is sucked by the compressor, and it increases the pressure and sends that higher pressure refrigerant into the condenser for next cycle. So same cycle repeats. Now this cycle will show you, this diagram will show you various pressure sides and components. Okay, you have a compressor here. Okay, this red color is the hot side, and the blue color is the lower pressure side, or chiller side. So you have vapor refrigerant coming like this, that is sucked by the compressor and compresses that to high temperature high pressure vapor refrigerant. Okay, so here you have a lower pressure lower temperature vapor refrigerant is sucked by this compressor and compresses that to high pressure high temperature vapor refrigerant. This high temperature vapor refrigerant, during its passage through the condenser coil, it rejects its latent heat to outside atmosphere and gets condensed here. So that means here you have a high pressure liquid refrigerant. Then you have a dryer receiver is there, dryer, that is it's just used for drying the water content of the refrigerant only. So then it's just a receiver, it's a storage tank only. Then you have this refrigerant is passing through this coil and it enters into the expansion valve where it expands. So after expansion valve, what happens is its pressure reduces. That is, liquid refrigerant pressure reduces and it vaporizes. So part of the liquid refrigerant vaporizes and part of the liquid refrigerant cools. So that chilled refrigerant, after cooling, enters into the evaporator coil and passes through the evaporator coil. Now during that, it absorbs the heat from its latent heat from the space to be cooled like this, and then this refrigerant vaporizes, whereas this space to be cooled becomes, temperature of the space to be cooled reduces, and this vapor refrigerant again enters into the compressor for next cycle. This is the same actual diagram of, this is actually the diagram of a vapor compression refrigerant system, that is as a window AC. Okay, schematic of a window AC, all the components of a window AC. Now once more we will see the various components. It has got a compressor. Compressor main function is to lower pressure lower temperature vapor refrigerant is sucked by the compressor and compressed to high pressure high temperature vapor refrigerant. It follows a law, P1 V1 raised to gamma is equal to P2 V2 raised to gamma, where gamma is equal to gamma is equal to Cp by Cv. Now another device called condenser. As I explained earlier, condenser is a device where it's a coil where high pressure high temperature vapor refrigerant, when it passes through the condenser coil, it rejects its latent heat to outside cooling media and gets condensed. That is, vapor rejects its latent heat to outside atmosphere and gets liquefied, where here you can see vapor minus HFG gives liquid, where HFG is the latent heat of the refrigerant. Now you have another device called expansion valve. Expansion device is simply an expansion valve, maybe a capillary tube or an expansion valve, where you are when the liquid refrigerant passes through this expansion device, its pressure reduces. It just controls the flow of the refrigerant. So what happens is pressure reduces and throttling occurs. It's a Joule-Thomson expansion occurs when it passes through the expansion valve. So that means the temperature of the liquid refrigerant reduces due to flashing. Next, you have evaporator. This is when after expansion you have a lower temperature liquid refrigerant. When this lower temperature liquid refrigerant passes through the evaporator coil, it absorbs its latent heat from the space to be cooled and gets vaporized. That is, liquid refrigerant absorbs its latent heat and gets vaporized. You have HFG is equal to, we have a liquid plus HFG gives vapor. So where HFG is the latent heat of the refrigerant. Now this is the again vapor compression refrigeration. I'll explain this diagram once more. Here you have a saturated vapor. Okay, this saturated after evaporator. Okay, so vapor refrigerant enters into the compressor. This compressor compresses that refrigerant to high pressure, high temperature of vapor refrigerant. So that is called superheated vapor. So when that superheated vapor enters into the condenser coil, here you have a cooling media. Here you have high temperature vapor refrigerant, which is at higher pressure. So it rejects its latent heat to outside atmosphere. So it gets condensed to liquid refrigerant. So now you have, after condenser, you have a saturated liquid is coming out of the condenser. That saturated liquid enters into the expansion valve where it flashes, so its temperature reduces and pressure also reduces. So this lower pressure, lower temperature liquid refrigerant enters into the evaporator coil where it sucks its latent heat from the space to be cooled and gets vaporized. This vapor refrigerant enters into the compressor for next cycle and same cycle repeats. So this is the TS diagram. Now this is the space to be cooled. So in the case of a refrigerator, this is the space inside the refrigerator and this is the space outside the refrigerator. In the case of air conditioner, this is the room to be cooled and this is the room out, this is outside air. Okay, air which is present outside the room. Now, and this is the your vapor compression system. Now this is the TS diagram. For a particular refrigerant, this is the TS diagram. Okay, this is the shape of the TS diagram and this point is called critical point. On the left side of this curve, you have a saturated liquid, and on the right side of this critical point you have vapor stage. This side is called superheated region, this is wet vapor region, and this is called saturated, this is called liquid phase. Okay, now for a, suppose you consider constant pressure lines. You have a constant pressure lines like this. From here one pressure line is coming like this, and this is the one pressure line. Another pressure line will be like this, from here touching this point like this, it goes like this, and third pressure line from here like this, it goes like this. Now you have two pressures, that is evaporator pressure and condenser pressure, that is suction pressure and delivery or discharge pressure. So suppose this is the suction pressure line and this is the discharge pressure line. So compressor 1, you have a saturated vapor entering into this compressor. So you have at lower pressure, that is suction pressure. So you have, this is a saturation point from here on this curve. Okay, so from here compression 1 2 is a isentropic process. So you have a isentropic process, means entropy should be a constant. It's a constant vertical line like this, constant entropy vertical line from this lower pressure to, that is from suction pressure to delivery pressure. So you have 1 2 will be a straight line, vertical straight line like this. Then after 2, it's a superheated region. So here it is a superheated region. Now 2 3 is the condensation. So here condensation, you have a superheated phase here. So that 2, the refrigerant at the condition 2, first it is to be desuperheated here, then only it condenses. Okay, so during its during this condensation process, the refrigerant rejects its latent heat to outside atmosphere. So you have, the curve will be like this, 2 from this point, then it condenses. So this is called 2. This curve is this curve, you can see that is the desuperheating, and then you can see the condensation process. Now then we have a expansion process. Expansion is a constant enthalpy process. So it's not a turbine. So turbine will be a constant entropy process, but in a expansion device it's a constant enthalpy process. Joule-Thomson expansion occurs here. So you have an enthalpy will be a constant, whereas entropy is not a constant in that case. So in that case entropy slightly increases during the process 3 4. So you have a curve, not a straight line like this, you have an inclined line like this. 3 4 is a expansion in a expansion valve. So the curve is not a straight vertical line, it's a 3 4 is a slightly inclined line like this. So that means this much vapor, this much part of the refrigerant is already vaporized, and this much part of the refrigerant is in the liquid form. So then 4 1 is the evaporation. So 4 1, you can see 4 1 is evaporation. From this 4 1 is evaporation. Again 1 is a saturation condition, and that is entering into the compressor for suction. So you have compression 1 2. So that is 1 2 is compression. Then 2 3 is condensation. 2 3 is condensation. So first from 2 desuperheating occurs, then it is condensation, then it is expansion 3 4. 3 4 is expansion. Expansion follows a curve like this. Isentropic expansion is not isentropic, it's isenthalpic process. So in a TS diagram it's a curve like this. Then you have 4 1. 4 1 is the evaporation. So 4 1 is evaporation. So this is the TS diagram. If you see the pH diagram, same cycle pH diagram, you have 1 2 is during 1 2 is during compression. What happens is enthalpy of the refrigerant is increasing. Okay, so because you are supplying some work input in the compressor, electrical energy, and that electrical energy is used for providing some work input to the compressor to the refrigerant. So you have enthalpy of the refrigerant is entering increasing like this. 1 2 is not a constant enthalpy. This is the pH diagram. Okay, pH diagram shape is like this. Now you have two pressures, 1 and 2, one suction pressure and delivery pressure. So in the case of a constant pH diagram, you have P, this is suction pressure, and this is delivery pressure or discharge pressure. So 1 2 is the compression. So 1 2 is the compression. 1 2 is not an it's actually it's a isentropic process, but enthalpy increases. So you have 1 2 a curve like this, where you have pressure is increasing, as well as in pressure is also increasing from 3.5 bar to 10 bar, whereas enthalpy is increasing from this point to this point. So enthalpy also is increased, the pressure is also increased. Then 2 3 is the condensation process. Condensation is a constant pressure process because there is no pressure change in condenser. So you have a 2 3 will be a constant pressure line, straight line, parallel to the pressure axis, parallel to the perpendicular to the pressure axis. Okay, so it's a constant pressure line. Okay, now we have expansion through the expansion valve. 4 3 4 3 4 is a constant enthalpy process. So constant enthalpy process, expansion in a expansion valve is a Joule-Thomson expansion. So it's a constant enthalpy process. So it's a 3 4 is a straight line like this. That means you have the point 4 is in the not in the not saturated condition, it is in the wet vapor region here between this curve and this curve. So this is the critical point, and this point, this side it is the vapor side, this side it is liquid side, this side is the superheated side, and this side inside this curve it is the wet vapor region. So after expansion, refrigerant is in the wet vapor region. Okay, now you have 4 so after expansion, this is the point. Then we have 4 1. 4 1 means you have evaporation. So liquid refrigerant is vaporized to saturated condition. Okay, so that is the pH diagram. Now you have, this is the various pH diagram for various conditions. Okay, now see, suppose suction side of the refrigerant is saturated condition, it will follow a curve, that is compression will follow a curve 1 2. Okay, if suction is saturated vapor is entering into the compressor, the compression will be a curve called 1 2. Whereas in the suction itself, if there is a 10-degree superheat, okay, then it will follow a curve 1 dash 2 dash. So then 2 3 2 dash 2 3, that is condensation. If 2 or 2 dash will be in the superheated region. Now 2 this much region or 2 dash this much portion, that is desuperheating. Then you have a condensation. After condenser, if saturated refrigerant is entering into the expansion valve, okay, so if saturated refrigerant is entering into the expansion valve, it will follow a curve 3 4. Whereas after condenser, if there is a subcooling of say 5 degrees, 5 degrees subcooling is there, means here the refrigerant will be in the subcooled region after condensation. So it will follow a curve 3 dash 4 dash, then you have evaporation 4 1 or 4 dash 1 dash accordingly. So hope you got some basic idea about simple vapor compression refrigeration cycle and its PS and TS and pH diagram. Thank you very much for listening to this lecture. Thank you.